So is my screen visible? Someone please response. So I got please.
Yes, screen is visible.
Okay. So it is visible now. It is written partial differential equation.
Yes.
Okay. Okay. So now I will start. Okay. So hello. Good evening. I am Somak, a research scholar at School of Mathematics and Statistics, University of Hyderabad. So today I will solve problems on partial differential equations, that is some assignment problems from previous years. So let me first show you the questions. Okay. So is it clear? Is this visible? Question number 2.
Yes.
Okay. So it is given, the question is that the partial differential equation, this 1 plus x cube y minus 2 ux uy uxy plus 1 plus uy power 4 ux is equal to 2 is what? It is of which equation and its order is what? So let me first write the equation. So, so first of all, it is a second order equation. Okay, let me first, I have to join something. So it is a second order equation. Okay. So the second order equation, because the highest order derivative is 2. U is the only dependent variable and independent variables are x and y. So it is a second order equation. The structure second order, because it is a second order equation and it is quasi-linear. Okay. So why quasi-linear? Quasi-linear means if PD is said to be quasi-linear, it is linear with respect to all its highest order derivative of the unknown function. So here you know that uiy, this highest order derivative, it is linear with respect to the highest order derivative. Means here is, if it is uiy square, suppose this equation is same, only I replace uiy by uy square, then it is not quasi-linear. Okay. So here everything is in, here every highest order derivative is linear. Okay. Again, I have to put admit on student. So this is a second order equation and highest order derivatives are uxx, uxy and uyy. So now you can check that so all the highest order derivative uxx, uyy, uxy and uxs, these are all linearly. These are appeared as linearly. So maybe I have, every time I have to admit to them. So sorry for the inconvenience. Your point is not here, so that I can ask. Okay. So, so it is a that highest order derivatives appears linearly in this equation. So it is a quasi-linear equation. So though people who join later means Rajesh or something. So let me tell once. So the question is that this is the a given PD. So you have to find its order and its type. Meaning, is it linear, quasi-linear, or semi-linear, something like that. Okay. So this order is 2 because highest order derivative is 2 with respect to the independent variables. So it is clear that order is 2. Now, what now? From that, as we know that equation is quasi-linear. If it is linear in all of its, uh, if it is linear with respect to the highest order derivative of the unknown function. So here unknown function is u, and highest order derivative is uyy, uxy, and uxx. These are these all terms appears linearly here. So it is a quasi-linear equation. It is a quasi-linear equation.
No, I
So
mean, maybe you can ask students first the definition of quasi-linear, and a linear and semi-linear is also a quasi-linear,
hmm,
right?
hmm.
So maybe you can explain why it is not linear or semi-linear.
Okay, okay, okay. So anyone who please
Can
can you
someone of you as okay,
give the
yeah,
definition
sorry.
of linear? What is the definition of a linear differential equation? Linear PD, I say. Anyone? Uh, Actually, I'm not able to see the screen. Who's present? Nitish Kumar, Amal, Rajendra. Anyone, if anyone answer, what is linear PD? Somadip Das. Please response if you know. But I'm saying that what is linear PD? Actually, every time I have to against something. Okay, I will tell this. So the linear PD is that suppose independent variable are x, y, and dependent variable is z. So if the PD is of the form, so I will write small p as del z del x and small q as del z del y. So I am considering only first order. Let me write here that it is first order linear PD. The definition is that it is a capital P, which is a function of the independent variable, to small p plus capital Q, which is again a function of only of independent variable, small q, equal to capital R, which is again a function of independent variable into z. So this is called a linear partial derivative. Maybe some other thing is there, some constant, say some. But this is called linear PD because the first order linear PD because only the derivatives, only the coefficient of these derivatives are only depends on the independent variable x and y, not on the dependent variable. So semi-linear is that p is a capital P. It is a function of x, y, and z. Depends on the dependent variables. Okay, I have to again admit one student. Mhm. This means that the dependent variable can appear arbitrary. Okay. Okay. So here, the answer is for this question. So for this question, the answer is it is of order 2 and it is quasi-linear because the highest order derivatives of the unknown function appears linearly. So now I will move to question number 4. Okay. So I think everybody saw the. Is it visible now? The screen is visible, right? So it was
Yes, it is visible.
okay. So question number 4 is that suppose two functions are given f and g. They are C1 functions. C1 is continuously differentiable, and the differential equation is u2 plus ux equal to 0. That is a transport equation. And ux0 equal to f of x for x greater equal to 0 and u0 is c of t. Now the solution is given as uxt equal to f of x minus t when x greater than or equal to t and g of t minus x when x less than t. So now from this given 4 options we have to find the pair of functions which are the solution or which u is a solution of this differential equation. So I will write this question. So I will write the differential equation first. The differential equation is u plus u of x equal to 0 for x greater than 0 and t greater than 0. U x comma 0 is of x. U 0 t equal to g of t. U x comma 0 is of x for x is non-negative and it is for t positive. Okay. So first of all, it is already given that the solution is of the form this uxt equal to f of x minus t whenever x is greater than or equal to t and g of t minus x whenever x is less than t. So, I want to ask how to solve this equation. Anyone response? Anyone? Amol, Rajendra, Ramesh, Somodeep. You know Lagrange multiplier or something to find the solution. You know, response please. Mr. Ramesh Joshi or Noora. No. Rajendra is no. Okay. Okay, I will tell. Anyone know how to solve this linear PDE? This is a linear because I will show the question again. Ut plus ux equal to the coefficient of u is 1 which is independent of x and t, and again coefficient of ux is 1. Amal or Ramesh or Somodeep Das. Okay, so sir, please help us to solve. Okay, Ramesh. Okay, now I will solve this. Okay, so I will use just. Okay, I have to again join someone. Just 1 second. Again, so Smiley and Cosi. Okay. So my question is, I will show the question to you, the guys who joined last. So f and g are two functions that there is an initial value problem, that is ut plus ux equal to 0, and here boundary condition is given as ux0, boundary condition is u0 t is gt, and this is initial condition ux0 equal to fx. So the solution is obtained from uxt equal to f of x minus t and g of t minus x on two conditions. So there are four options given, which of the following pairs gives the solution of this initial value. Okay, so I will solve this. Let me solve this. So solution. So I will use Lagrange multiplier method. Anyone of you know this method? First of all, anyone please respond. Unmute yourself, or otherwise type in chat box. Lagrange multiplier method. Anyone? Mr. Anyone? Ramesh or Somadip or Rajendra? Okay, I will tell them. Okay. So Lagrange multiplier is that there is an auxiliary equation. It is called Lagrange auxiliary equation. What is that? That is nothing but I will write the coefficient. What is the coefficient of ut? It is 1. What is the coefficient of ux? It is 1. And here it is 0. Okay, so I will I will write like this. Auxiliary equation, it is an ordinary differential equation. I will write d of t. D of t means derivative with respect to t by, I will write the coefficient of ut here, that is 1, equal to t of x by coefficient of ux, that is 1, and d of u. Coefficient of, there is the coefficient, what the terms in the right hand side, total is 0. This term will become here. Okay. So auxiliary equation becomes dt by 1 equal to dx by 1 equal to du by 0. So this is the method to find the auxiliary equation. Anyone any question? How I write this? Any question from your side? Nura or Amol, Rajendra, Ramesh. Any question till now? I just write dt d of t by what is the coefficient of ut plus d of x by what is the coefficient of ux and d of u by 0. That is what is in the right hand side. Now I will solve these equations. These are called simultaneous linear equation for OD. Okay, these are all linear and simultaneous equation because there are more than one equality sign. So I will move on to next page. So my equation is dt by 1 equal to d of x by 1. Now since it has two equality sign, these equations, so I will consider the first two equations, then I will solve, and I will again take the last two equations and I will solve like that. So consider, this is the Lagrange multiplier method. Okay. So consider first two ratio, two equation, first two ratio I say. Okay, so again someone wants to join. Considering the first two ratio, I will get dt by 1 equal to d of x by 1. So I will get 1. After integrating, so this means dt equal to dx. So after integrating, what I will get x equal to t plus c something, c1. So x minus t equal to a constant c1. So again I consider last two equations, last two ratios also. Then what I will get? I will get d, last two is what? Dx by 1 equal to d of u by 0. So this means u equal to constant. D of u is 0. Na? If I multiply like this will multiply there, and this will multiply there. So d of u equal to 0, so u is c2. So what? So these x minus t equal to c1, this equation, and u equal to c2. These are two characteristic for this differential equation. Now what is the general solution? General solution is that this c2 equal to any function of c1, where function is phi is a continuously differentiable function. Continuously differentiable function. So I will the general solution for this Lagrange multiplier method is like that. Okay. So what is c2 here? So c2 is u. So u is a function of x and t. So that is a function of, I get c1 is x minus t. So up to this I think it is clear. Any question? Any question? Please unmute and tell if you have any question. Anisha, Ramesh, Rajendra, or Amal, Somadip Das. Hello, can you hear me first of all? Please help us to start. Okay. Hello, hello.
Yes, you're audible.
So Rajendra, is it okay? You can unmute yourself and tell. No doubt. Okay. You can unmute. No problem. I want to hear your voice also. So it will be better. Somadip Das or Anisha or Ramesh, last day you talk, so you can tell here also. Ramesh Joshi. Okay, so I will proceed. No doubt, you say.
Sir,
Yes,
you are
come.
explaining. We are getting it, sir.
Okay. Thank you.
Yes.
Okay. Okay, so I get the solution like this. Okay. Now what is in the question? Question is given that f and g already given to function. Let me solve the question again. Question is that f and given f for f and g is in C1. So uxt is a solution like this: f of x minus t, g of t minus x. Okay. So the solution they are giving us uxt equal to f of x minus t whenever x is greater than or equal to t, and g of t minus x whenever x is less than t. Okay. So uh, So suppose this is x-axis and this is t-axis. So you know the x equal to t line, right? X equal to t is passing through origin and making an angle 45 degree with the positive x-axis. This is x equal to t line. Okay. So here the f is given here. Whenever x greater than or equal to t, here it is f. And okay, again I have to admit someone. Just it is g here. Just once. So let's okay. So here it is x equal to t line and f is given here, g is given here. So at and u f and g are c1 function. C1 means the first order derivative are continuous. F and g is in c1, c1 0 to infinity something given. Okay, so if u is a function of x and t which is given by f and g, so u should be also c1. That is at u should c1 for from 0 to infinity anywhere. Okay, that is at x equal to t also, x equal to t, u should be continuous and differentiable. U is in c1 0 to infinity for all x and t. Okay, so some this function is breaks that solution breaks at this here x equal to t line. So if I go from here, or from here to reach at x equal to t, then u should be continuous. Okay, so this so if I put x equal to t here, so u of t comma t is what? It is equal to f of 0 and x greater than or equal to 2, x equal to g of 0 and x less than t. But what I said that u should be continuous over the whole region for any t. Then what happened? F0 equal to g0 holds, because these are two different. Suppose f0 and g0 are two different. Okay. Suppose f0 not equal to g0, then I cannot say that u is continuous. U is continuous at t, because at x equal to t it breaks. So for continuity, for u to be in c1 or u to be in c, I say f0 equal to g0 holds. Okay. F0 equal to g0 holds. So just I have to admit again 1%. Okay, so now f0 equal to g0 holds. Yeah. So by checking options, go the from the options given below, which of the following choose pair of functions such that u is a solution. So you can see that f0 is 0 here for option A, and g of 0 is 0, sin 0 is 0. For option B also f0 is -1, sin 0 is 0, and -1, g of 0 is what? -1, because cos of 0 is 1. For option C also f0 is 1, g of 0 is 1, cos 0 equal to 1. And for option D, f0 is 0 and g0 is 1 minus 1, 0. So you can, so what happened is that for all options A, B, C and D, option A, B, C, D, for all options f0 equal to 0 holds. That is u is continuous. That means u belongs to only C up to this. But you have to check that you have to check that u is in C1, right? C1 means its derivative also continuous. Now I have to check only the derivative case. So for this, to check this derivative, so first of all, let me draw again x and this t, and here x equal to t line. So the solution is what the question is giving, that u x comma t is f of x minus t whenever x is greater than or equal to t, and 0 of t minus x whenever x less than t. So f and g are c1, it is giving f and g are c1. So here it is f and it is g. So you know that in this region f is differentiable, and in this region f is differentiable, and in this region in this region g is differentiable, and in this region f is differentiable. Okay, so but u may not be differentiable along this line, because along this line x equal to t, along this line the function breaks, right? So function breaks means maybe it may happen that it loses its differentiability. So I have to check the differentiability along this line. So only to check differentiability along x equal to t line. Okay. So now I want to check along only check differentiability along this line, because other region f u is already differentiable because u is a function of f and g only. But at where it breaks, the function breaks at x equal to t, right? F and g. So I will check along this line. So I want first to do this. I will fix any point here. Fix any point xi. Say. So I will just fix xi. So fix any point xi on that line. Fix xi any point x equal to t line. Okay. So now I want to find the differentiability. That is, I want to check then C1, that is continuously differentiable. Its derivative is continuous or not. That is, I want to check limit x tends to xi plus derivative is continuous or not. Del del x at x comma xi, is it equal to limit limit x tends to xi minus del x comma xi. So what is del u del x whenever x tends to xi plus? X tends to xi plus means x greater than xi, and xi lies on this line. That means this point is xi comma xi, right? This point is xi comma xi. So x tends to xi plus means x is greater than xi, right? And x is coming from here. So x greater than xi means it is f, and f is differentiable, I know, because f and g giving us c1, 0 to infinity positive. So del u del x is f dash. So limit x tends to xi plus del u del x is f dash x minus xi, because u is f of x minus t. So u dash del u del x is f dash x minus t. Now I want to find the xi point. So x minus xi. And similarly here also it is limit x tends to xi minus. So it is coming from this side. X tends to xi minus means x is less than xi. This is coming from this to this line. X less than xi means x less than t. That means g. So g of xi minus x. The derivative of g of xi minus x is minus g dash of xi minus x. Right? So it is minus g dash of xi minus x, because because nothing, g of t minus x is there, t minus x, and I just want the derivative with respect to x. So g dash t minus x into derivative of t minus x with respect to x, that is minus 1. So minus g dash t minus x. Now t is replaced by xi because I fixed xi at this line. Now f and g are c1 functions. So c1 means this derivative is continuous. So x tends to xi, this limit will be considered inside f dash, right? So x minus xi is 0 equal to minus g dash 0. Okay, understand up to this? Any question? Mr. Somodip Das or Biplab or Ramesh or Rajendra, any question till now? You can unmute yourself and tell. No sir. Okay. Ramesh, tell. I get
Yes,
you.
continue, sir. Continue,
Okay,
continue.
okay, okay. No question. Okay.
No, sir.
Okay, fine. Okay, so I got another condition is that f dash 0 equal to minus g dash 0. Okay, someone wants to join again. So f dash 0 equal to g minus g dash 0. Now I will again show you the options. What are the options given? Already f0 equal to g0, all the options satisfies, right? So tell me, Ramesh, f dash 0 is what for option A? Ramesh, hello, hello Ramesh, can you hear me? Hello.
Zero, sir, zero.
Now why 0? F dash 0 I am saying. What is f dash x? F dash x is minus 1, na? Rajendra?
Yes, sir.
So
Yes, sir. Yes.
f dash x is minus 1. So I just put x equal to 0. So f dash 0 is minus 1. What is g
Okay.
dash 0? G dash t is what? Sine derivative of
Cos
sine
zero.
t.
Cos. Cos t.
Cos t. Cos of 0 is what?
One.
Yes, absolutely. So f dash 0 equal to minus g dash 0 holds. In this case, this condition holds or not? Tell me. F dash 0 you tell f dash 0 is minus 1
Yes, sir.
and g dash 0 is 1. You tell me
One.
this thing, right? For option A.
Yes, sir.
So this condition is satisfied, right?
Yes.
Minus 1 equal to minus of 1 equal to minus 1. This condition satisfied, so option A is correct. Now option B tell me. Anyone? Rajendra or Ramesh or other persons? Somadip Das, Biplav, Anisha. Just tell me. No problem. If you are not able to answer, no problem. I will tell you. What is f dash x? It is cos x, right? Ramesh? Sin x. What is the derivative of sin x? Cos x. And 1. What is the derivative of 1? That is 0. So f dash 0 is 1 and g dash 0 is what? Tell me, Ramesh. Hello. 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 Tell me. I will show you the question again. Okay, let me write it. Then fx equal to sin x. Fx equal to sin x minus 1 and gx equal to what is given, and I have to check again. T minus cos t. G of t equal to t minus cos t. Okay. G of t equal to t minus cos cos of t. Okay. So what is f dash x? Tell me anyone. Anyone. Tell me anyone. Just I want to wait for 1 minute.
Cos 6.
Tell me. Hello.
Cos 6.
Yes, absolutely. Who is the guy? What is your name?
Biplav.
Okay, Biplab. So, what is G dash T?
1 plus sin t.
Yes. So, F dash 0 is what? In this case, F dash 0. Cos 0 is what? 1, na?
F dash 0 is
F dash 0, I put x equal to 0 only.
1
Cos 0 is 1. And what
and
is?
g dash 0 is 1. So this does not satisfy the
Ah,
condition.
excellent. So, option B is false.
G dash
Now,
0 is 1.
Sorry? Hello, Biplab. Here F dash 0 not equal to minus G dash 0, na?
Yeah, g dash 0 is 1.
So, this option is false
Yeah,
because
yeah, yeah.
now option C is what? Let me show you again. You tell me just quickly what is option, what is F dash 0 here? For option C I am saying.
F dash x will be minus cos x. Then f
Okay.
dash 0 will be minus 1 and z
Uh,
dash 0 will be uh, minus 1.
Excellent. So F dash 0 not equal to G dash 0 again for option C. A minus G dash 0.
Yes.
I have to show which those cases for which F dash 0 equal to minus G dash 0. But for option C I gave that F dash 0 is minus 1 and G dash 0 also minus 1. For option C, if dash 0 is minus 1 and G dash 0 also minus 1. So it's not satisfied. Option is false, right? Now option D is there. Option D, tell me what is f dash x? F dash 0, 1.
If that you will be 1, yeah,
And 0 dash 0 is what? Minus 1.
-1.
So is it satisfied or not?
Yeah, it is satisfied.
Yes, f dash 0 is 1. And so, sorry. 0 dash 0 is 0 dash 0 is minus 1. So here f dash 0 equal to minus 0 dash 0 satisfied. So option A and D are correct. Okay. Understand, Biplab? Two of this
Yes,
question
sir.
you understand, no? Okay. So let me move to another question number 6 here. Okay, there I have to again join another person. Uh, Ajit Kumar. Okay. Hello, Ajit. Hello, Ajit. Can you hear me? Okay. So I'll show you the question. I'm solving some problem from partial differential equation. I just solved already 3 questions. Now it is the fourth one. So I solved 2 questions and it is the third one. So is this screen
And
visible? Tell me.
yeah, screen visible. I'm Saikat. I'm just telling the students that next time, please try to join within 15 minutes. Okay. Otherwise, uh, I
Uh,
can't get you in.
yes. In every classes you have to join within 15 minutes. 6:15. Not it's already 6:45. Okay. 6:47. Okay. So okay. Let's move to question number 6. It is very easy question. So it is given that there is a right circular cylinder and any point on the cylinder is there. You have to find the which of the following parametric curves from these given options that has the property that the curve lies on the cylinder. That is, this curve satisfies x square plus y square equal to 1 and having tangential direction at p is in the direction of this. Okay, so it is very easy, no need of any PD. Why I am telling you? Okay, so P is on C, right? 1 0 0 because 1 plus 0 equal to 1 square plus 0 square. And which of the following parametric curves has the property that the curve lies on the cylinder? So what do you mean? Lies on the cylinder means this is satisfies for all t, is cos t, sin t and t. That is x value is cos t, y value is sin t, z value is t. So lies on the cylinder means it satisfies x square plus y square equal to 1, this identity, and z is in R. So anyone tell me that option A is okay, means it up to this it lies on the cylinder or not? Anyone? Biplab or Somadeep and other persons there. Oh, Biplab is there. Other person Somadeep or Anisha, tell me just within 2 minutes.
Uh,
Who is the speaker?
Sir, here cos
Biplab.
square
Okay.
square
Uh,
t is 1.
you have to show that
So
you have to. Oh, hello.
cos square t plus sin square t is 1 for
Uh,
any t. So it
yes.
satisfies the condition.
Okay. And okay. So move on to option D. Tell me. 1 square plus 0 square is 1. So it is on the cylinder, right?
Yeah.
And t is in R. So z belongs to R. So option C. Cos square 2 pi t plus sin square 2 pi t is 1, right? Cos square theta plus sin square theta equal to 1 for any theta is in R. You know now this. For any theta in complex also it is true. You know this. Biplab. Hello.
Yes.
So option C is okay or not?
Yeah, option C is also okay.
Option D.
Yeah, it is okay.
Okay. So up to these
All the
all
points belongs to me.
up to these all are satisfied, right? But you have to
Yeah.
check another condition and having tangential direction at the point at P in the direction of 0 1 1. You know anyone know? People you know what is tangential direction? Let me move to the next page. Biplab. Hello, Biplab, you know? Just tell me. No, if you tell me wrong, also no problem. Tangential direction, you know, any parametric curve it is there. Okay, let me draw this quickly. If it is possible to draw. Then, uh, suppose there is a cylinder. Okay, okay, my drawing is not so good. Not, I hope you understand. So I will first write x. This is y. This is z. Sorry, this is okay. So 100 is where? 100 means here. X is 1, y is 0, z is 0. 100. Let consider this point. Let me change my color so that you can understand. This point is 100, right? I am considering. That's the small cylinder I draw. What is 0, 1, 1? Tell me. 0, x is 0. No need to go this way. 1 is along this way, 1. So this direction is 0, 1, 1 direction. This direction. And okay, and this point is actually 0, 1. If I take this height is equal to 1. And this circle is what? X square plus y square equal to 1. Right? Biplav, you understand? Biplav and yeah, other persons who are there.
What is
Hello? Yes, tell me. What is your question? Yes, Biplav?
what is the direction here?
Direction I am taking in this direction. I am taking I am taking uh, along z axis actually. This is parallel to z axis. I am taking 0, 1, 1 point is where it is in here, right?
Yeah, yeah, it is here.
Because 0 square plus 1 square is 1, right? And 1 belongs to R. So it satisfies all the condition what is in the given in the question. Therefore, it is C here. In C, what is the cylinder? C is that x, y, z in R3 such that x square plus y square is 1. It is satisfied. And z is in R. So here 0 square plus 1 square is 1 and 1 is in R. So 0, 1, 1 lies on this.
No. The point is you have to calculate the tangent at that point.
I have tangent, yes. Tangential direction means what? For any tangential direction. Now suppose a curve is given in parametric form xt, yt and zt. Means okay. Like this, right? So I got right like this. Hello?
Sorry? Huh?
I am saying like this now.
Yeah. I guess okay. I mean, all the curves lies on the cylinder. That is fine. Now we have to check the tangent at the given point. And I guess there is one way that check individually for each given option, and another is assuming the curve is xt, yt, and zt, right?
Fine.
And it will be perpendicular to the normal, and normal will be given by gradient of the surface.
That is okay, but
Right.
just for any curve, suppose xt, yt, zt is given parameterization. So what is the tangent direction? I'm asking to the person who are there, except Soipat. Biplav or Somodeep or Anisha, anyone response or in chat box you can write. Suppose a curve is given like xt, yt, z of t. So what is the direction of each tangent? Without going for partial differential equation, you can take.
You guys are encouraged to participate in this discussion. I mean, this is supposed to be not supposed to be a lecture. This is supposed to be a tutorial session. So it will be better if you guys, all of you, can ask question or give some ideas. It may be wrong. That is fine, but you should participate.
So Tangential direction is nothing but it is derivative with respect to the parameter x dash t, y dash t, z dash t. This is called tangential direction. Okay, you know now that dy dx represent tangent to a curve. Suppose y equal to f of x. Okay, Biplab or any other. Dy dx if you know this, Biplab. If, so, if suppose parameterization is there, so I can write it as dy dt by dx dt. So component wise, what is that? Component wise it is a tangential direction. Component wise it is another tangential direction. Biplab or anyone response? Yes. Biplab.
Yes, sir.
You
So
know that dy dx
we have
equal.
to check
Tell me, tell
at
me. You have to check that
are you
which
saying that to this uh, what is the
tangential
tangential
direction
direction
at P is in the
at
direction
zero
of.
one one
Uh,
of this curve?
I'm saying, I will tell you. We have to check. We have to check that for which there exists at P. At P means at what is the P point? 100, right? So at this point, for which T equal to T0, for which T0,
So
x dash T0, y dash T0, and z dash T0. This is in the direction of 0, 1, 1. This means this is some constant multiple of some alpha into 0, 1, 1. Right? Is not it? It is in the direction of 0, 1 means what? It can be 0, 1, 1 or otherwise it is a constant multiple of 0, 1, 1. Right, Viplav? At P means at 100.
yes, sir. So
So, so I will show you the questions again.
direction,
In the direction of 0, 1, 1. In the direction of 0, 1, 1, either it is in 0, 1, 1 or it is parallel to 0, 1, 1. Not in this way. This is wrong, I think.
okay, okay.
Ajay, suppose it is the surface. It is the surface of the cylinder. So here it is, right? 0, 1, 1 point is here. So you have to find any tangent which is along this direction or parallel to this direction. Either parallel or along for this card. So, uh, okay, so I will explain this first. So at P equal to 100, what is from the option A? What you get? Option A is that cos t, comma sin t, comma t. Okay. So for what t? When I am saying t equal to t0, for what t0 this will satisfy? Tell me. For what t0 this will equal to 100. Tell me, Biplab. T0 is what? T equal to T0 equal to 0, na? For T is equal to 0, what is this? 100, right? Biplab? Or any other person? Understand?
Yes, sir.
Okay, so so it is 100, right? Now x, what is x dash? X dash y dash z dash minus sin t,
Yeah,
cos t and 1. Is it 0, 1, 1 at t equal to t0? You have to find at t equal to t0 that I told you just now. Is x dash t0, y dash t0, z dash t0. Which is alpha. You have to check this condition is hold or not for this t0. It is holding. Sin 0 is what? T0 is 0 here. Sin 0, 0, cos 0, 1, 1. So option A is true, right? So what is option B? Option B is 10t. 10t. So 10t. This is a parameter. This is a parametric representation. So P point lies there. P is 100. P point lies in this card, right? So if I compare with 1 0 0, what we get? T equal to what? 0, right? Develop T equal to 0, 1 0 are identity. 1 0 equal to 0, T equal to 0, right? Develop this part.
Yes, sir.
What is x dash t 0, y dash t 0? This is xt. In option, this is, let me write option A. Whereas this is option A. So this is this is option A. This is option B. So option A is true. Option B is t equal to 0. So what is x? This is xt. 1 is xt. Y is 0 is yt. And z is t is equal to zt. So what is x dash t? 0. What is y dash t? 0. What is z dash t? 1 na. So is it equal to alpha into 0 1 1?
One.
Huh? Is it equal to alpha
No.
into? Is it possible? Possible or not? Question mark. Tell me.
No, sir.
Not possible for any alpha real number. So option B is false. Okay? Option B is false. Option C is what? Let me check again. Option C is what is option C? Cos 2 pi, sin 2 pi, cos 2 pi t, sin 2 pi t, 2 pi t. Okay? So cos, so we have cos 2 pi t, sin 2 pi t, and 2 pi t. Right? So you have to check that for which t equal to t naught this 1 0 0 this point lies. For which t? Tell me. I have to check that the question is what? Question is given that
Equal to 0.
yes, question is given at the point at p. So you have to check for which t0 it is happening. It is t equal to 0, right? So what is x dash t0? Tell me. Minus 2 pi into sin 2 pi t, right? X dash t first. Sin 2 pi t. So 2 pi cos 2 pi t and 2 pi, right? I am just differentiating. Understand, Viplav? Or other at t equal to 0 I have to
Yes, sir.
cancel. So what is sin 2 pi t? Sin 2 pi into 0, 0. What is cos 2 pi? Tell me. Cos 2 pi? Viplav, anyone knows cos 2? What is the value of cos 2 pi?
Cos 2 pi.
Cos n pi, you know cos n pi?
1. Sorry, it will be 1. Yes.
No, it will be 1. Cos n pi is minus 1 whole to the power n for any natural number n. So cos 2 pi is minus 1 whole square. That is 1. Okay? And 2 pi. So it is in the direction of 0 1 1 or not? 0 1 1. It is in the direction of 0 1 1.
Yes.
Alpha equal to 2 pi. Alpha is a real number. Anyone. Alpha belongs to R. So option C is correct, right? Develop. And what do we write option D? Just moving to next page. Option D is what? Option D is 102 pi t. Tell me 102 pi t. First you have to check at which for which t it is the p point is occurring. P point is 100. So t is equal to 0. Develop. Now we have to check another condition is derivative at t equal to 0 is 0 in the direction of 0 1 1 or not. What is derivative? 0 0 2 pi at t equal to 0 it is same as 0 0 2 pi because it is independent of t, right? So this is not equal to alpha into 0 1 1 na? Understand? Viplav?
Yes.
So option D is false. So what are the correct option? A and C. Right now? A and C. Viplav?
Yes. And
Another person, Somadip Das and Anisa, I did not hear from you till now. Any, you can tell in chat box also. Rajendra, I think he left. Okay, no problem. So Anisa and Somadip Das, please tell. No hesitation. You can tell anything. It is okay or not, brother? Brother or sister?
Yes, sir, it's okay.
Okay. You understand now? Tangential direction. It is
Yes,
just
sir.
tangential direction is parameterization. It is just derivative with respect to the parameter. Okay, so I want to move to next problem. That is, I will discuss method of characteristic here. This problem. Problem number 8. Okay, is the session is useful or not? In Biplab, it is okay. Biplab,
I mean, you guys, have you guys any suggestions? I mean, what
ah,
about the problems and everything?
you are you solve your week, you check your week one problems, na assignments. Biplab, so
Maybe first you go through the lectures, then you try the assignments yourself, and you can look at the we are actually discussing the previous year assignments, so you can try those also, and you can try the this year assignment also, and problems are quite similar. So if you guys have any problem in some particular type of problem,
then
we
you can
can do
look at
that type of problem, not exactly the assignment problem, but we can do similar problems. And but you have to uh, try and tell us what
yes,
kind of problems do you want us to do. Okay. And
yes.
I guess it is already 7:05, so it is almost.
But I will tell the method of characteristic once. That is,
Okay, yeah. Hmm.
is it okay now? Biplav and other Anisha, Somadip Das, he did not even tell anything. Hello, Mr. Somadip Das. Hello. I don't know. Maybe. Okay, no problem. Oh, he left. Okay. No hesitation, brother and sister. No problem. Okay, so I will tell this problem how to solve this quasi-linear equation. So let me write the problem. Again, someone that wants to join. I think Mr. Somadip is there. No, Shashank. Okay, hello Shashank. So my screen is visible, Shashank.
Yes, sir.
Okay, so I want to solve this problem, this Cauchy problem. Huh? So
Okay.
follow my process. Follow what I'm
Yes.
doing. I'm writing the question, the equation actually. So equation is that u into ux plus y uy equal to x, and initially it is given that u 2x comma 1 is equal to 4x, right? So I will use method of characteristic. You know anyone? Method of characteristic. Or how to solve this? Biplav or Shashank or Anisha? Biplav?
I don't know this question.
Okay, don't know. Okay, I'll tell, no problem. Okay, actually, method of characteristic is that suppose I have suppose t is the parameter, and the characteristic curve is xt, yt, and ut. For any t is in for suitable t is greater than or equal to 0. Time is always non-negative. So xt, yt, and ut, these are characteristics of this equation. This means this satisfies this equation, right? So this means the method of characteristic. It is a method. I will tell this. But what is the method? Method is that you have to differentiate x with respect to this parameter t. So dx dt will be equal to the coefficient of ux. What is the coefficient of ux? U. Screen is visible now. What is coefficient of ux? Biplav.
You.
Ah, tell me. U. What is now dy dt is coefficient of uy. What is it? Y na
Y.
coefficient of uy, and du dt what will be the thing that is in the right hand side. Anything. What is this? Here it is x, right? Hello.
Yes, sir. Yes.
Okay. So I method of characteristic tells us that it is a what? It is a PDE thing, right? It is a PDE. And now I transform it into an ODE, first order ODE. Understand? I just
Acha,
consider
yes, sir.
I just consider only coefficients of ux, uy, and what is in the right hand side, and I write dx dt as coefficient of ux, dy dt as coefficient of uy, and du dt is x. Okay. Now I will solve this equation with what is the initial condition. What is what is x initial x0, y0, and u0 is what? It is nothing but it is already giving that u of 2x comma 1 is 4s. This means this is the initial condition. So I will write I take t as a parameter. Okay, I will write then what is it? 2t, not t, I will say 2 alpha, because in the question it is giving alpha, I think. Alpha is a family index, right? Is it family index by alpha? So I will write alpha here, okay? Biplab. So 2 alpha. What is y0? Y0 is 1. What is u0? U0 is 4 alpha. Somebody wants to join here now.
Sir, I have one question.
Yes, tell me that. What is it?
U is a function of one variable or two variable?
U is a function of two variable. Listen, just listen. One minute. Here I am writing in the right hand side. U is a function of two variable. Partial differential equation means it has two independent variable. It has more than one independent variable and only one
But
dependent variable. Huh?
in but after the line method of characteristic, you write xt, comma yt, comma
Huh.
ut.
I
Here,
parameterize. I parameterize. Ut means u of xt comma yt. This is
acha,
the
acha,
thing.
acha, acha, got
And
it.
xt is a function of t, yt is a function of t. So I can simply write u at t
Oh,
like that. You understand now? Mane ut
oh yeah,
is
got
like
it.
this. I have to write like this. Actually, you are right. You are absolutely correct. Let me erase this. I will write xt comma yt here. Otherwise, maybe it makes some confusion. You are right. Uh, is it u of I will write u of xt comma yt. You are right, Biplav. You are excellent. Xt comma yt. So no need to write this line.
So actually, xt comma yt, if you vary t over real line r, xt comma yt will become a curve, and
Uh,
along that curve, u is a function of only one variable, which is t, right? I mean, you cannot just make a function with two variable to a function of one variable. I mean, it is not possible.
uh, I
Uh,
it's
Here we are looking at the curve xtyt. That's why.
I have to write.
I hope I'm right.
Uh, you are right. You are right. Biplav also right. I have to write u of x0 comma y0, not u of 0. Okay, Biplav. That is 4 alpha. It is given now initially here. U of x0 comma y0 is 4 alpha. Where I took x0 as 2 alpha, y0 as 1. Biplav, you are right. Okay. So now I want to solve this system of ODE with this initial condition. So I'm considering y part first because it is easy to solve. So what is okay? We'll go step by step. Dy by y equal to dt. You know, Biplab, or who is the other person there? I don't remember their name. Anisha and so on. Other person tell me. It is okay now. Hello.
Yes.
Okay, okay. Okay, I'm integrating. What is dy by y? Integration? Biplab. Hello? People tell me?
while log y
Uh,
equal to t plus c.
I will take the constant at log C. Log C1, okay?
Okay.
Just for simplicity. So what is y? Tell me. C1 into e power t, na? You know this step. Biplab, who tell me this thing?
Yeah, yeah.
Yes, sir. Yes, sir.
Okay, who is the other person? Yes, sir. Who is this? I don't know your name, brother.
Sasank.
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 Sasank, it is okay, na? Sasank?
Yes, sir. Yes, sir.
Okay, okay. Now I will put t equal to 0. Initial condition is given at t is 0, right? Y0 initially. So y0 is what? Y0 is 1, right? So 1 equal to what? C1 into e power 0 is what? 1? C1 into e power 0. So e power 0 is 1, right? You know what you do, I think. So C1 is 1. So I get yt equal to e power t only, right? Now I want to, the another two equations are what? Dx dt equal to u and du dt is equal to x. So you know how to solve this system of ODEs. There are two methods, or maybe many more methods. Biplav or Sasank or Anisha, tell me, anyone? Hello? No, yes or no? You know or not?
No, sir.
Okay, okay, no problem. No problem. I will tell you. Okay, so uh, I can write these two equations as this in vector form, right? Therefore, is it okay? This line is
Are
okay?
you gonna use matrix form?
Have matrix for matrix or vector, anything. Matrix itself. You know dx dt equal to ax. How to solve this equation? Autonomous system of linear ordinary differential equation. Biplav,
I don't consider.
you don't know. Okay, I will tell. Then it will take some. Okay, I will tell.
No, the matrix form.
Huh? What?
Not
I
a
know that
problem. I
this
mean,
is matrix form.
just do it with taking one more derivative and solving second order
That
ODE.
will be better. That will be better, I think. Okay, actually you don't know this method, na? Anyone knows this method? Then I will tell. Otherwise, I will tell some simpler method. Biplav or you know this method? Sasan.
I don't know, but
No,
it
sir.
will be help. It will be nice if you if if you say this right now.
Okay, okay, okay. I will tell. Definitely. I will tell. So I will tell this method. Actually, I am writing ddt of x comma x u equal to this. Okay, this is the you know matrix multiplication, right? If you multiply this matrix with u and x, this you get this, right? So I write this equation as dx capital X dt equal to a into x, where a is a matrix, x is a vector, where x equal to x comma u, and a is this matrix is a. Understand? Matrix multiplication you know na?
Yeah, got it. Yes, sir.
Okay, you know eigenvalue. You,
Yes.
you know this term eigenvalue, eigenvector. It will be solved using eigenvalue and eigenvector actually. No, no, don't know, no.
Yeah, I know eigenvalue and eigenmatrix.
There is a minus lambda determinant equal to 0. We have to solve this for which value of lambda this is coming. This is lambda square minus 1 determinant. So lambda equal to plus minus 1. Okay. Now eigenvector you have to find eigenvector means for which x. ax equal to lambda x has a non-zero solution. For which lambda this ax equal to lambda is no solution. Where lambda is plus minus 1. X is the eigenvector, lambda is the eigenvalue. So what is A? A is 0, 1, 1, 0. X is x1, x2, I will write. Eigenvector. I have to find this x1 and x2 equal to lambda x. Lambda I took, first I took lambda equal to 1. Then I took lambda equal to minus 1. Okay? So lambda is 1, sorry, 1 into, okay, let me write it clearly. Just 1 second. Equal to 1 into x1, x2, right? So this gives x2. Matrix multiplication big log.
Yes,
This is x2 comma x1, na x2 and x1, right? Equal to x1, x2.
yeah.
So what you will say? x1 equal to x2. What is this implies what?
X1 equal to X2, yes.
x2 equal to x1, x1 equal to x2. So x1 equal to x2. I have. So
Yeah.
the vector is what?
1, 1, generated by
Yes,
1.
excellent. 1, 1. X equal to 1, 1. X is 1, comma 1. For lambda equal to minus 1, again you have to same thing. So you will get x2 comma x1. The left hand side is same, na? Ax is x2 into x2 comma x1, x2 and x1. Just lambda is put at minus 1 because I get lambda equal to plus minus 1. For lambda equal to 1, I get eigenvector 1 comma 1. For lambda equal to minus 1, I will get what? Minus x1 comma minus x2. Biplav, you understand? Or any other person? So, understand, Biplav?
And
Huh?
yeah, here it will be generated by 1 minus 1.
Minus 1 1 or 1 minus 1, anything you can write.
Mm.
So, what is your then the solution is given by the solution how it is given? Oh, sorry. Is it visible? Hello? Visible, na? Page is visible. My handwriting.
Yeah, it is visible.
Okay, actually the solution is given by the solution is x comma u, right? It is given by some c1 into e power lambda t lambda equal lambda 1 I say into the eigenvector corresponding to lambda 1 plus c2 e power lambda 2t into the eigenvector what I wrote 1 comma minus 1, right? So it is c1 lambda 1 is 1 and lambda 2 is minus 1. I just rename 1 as lambda 1 to minus 1 as lambda 2. So c1 e power t into 1 comma 1 plus c2 e power minus t into 1 comma minus 1. So it is c1 e power t plus c2 e power minus t and c1 e power t minus c2 e power minus t, right? Biplav? So now x of 0 is what? X of 0 and e
Yeah.
of 0. I put t equal to 0 because initial I will consider. Initial it is what? That's plus 1. C1 plus C2 and it is C1 minus C2. So what is C1? Can you tell me? It is x0 plus u0 by 2 and what is C2? It is x0 minus u0 by 2. You understand? You just solve C1 plus C2 equal to x0 and C1 minus C2 equal to u0. Then find C1 C2. Just adding. If you add these two equations, you will get this. Understand, Biplav? This follows
It,
this. Or other is there. Rajesh, or what is it? Shashank.
Yes, sir.
Anisha,
Yes, sir. I'm getting.
Anisha, you please tell something. Hello?
Yes.
Okay. Okay. So, so what is the solution by the way? Solution I get, what is xt? Tell me, xt is c1 e power t plus c2 e power minus t. c1 is x0 plus u0 by 2 into e power t plus x0 minus u0 by 2 into e power minus t. And what is ut? Ut is x0. Ut is c1 minus only c2 is there minus by 2 into e power t minus x0 minus u0 by 2 into e power minus t. Now, what is x0, y0 is x0, u0, sorry. I told you maybe here. So it is here I told. X0, y0, u0 is what? 2 alpha, 1, 4 alpha. Okay. So I will put this only. So what is xt? Xt is 2 alpha, 1, 4 alpha. Remember, 2 alpha, 1, 4 alpha. So x0 plus u0 means 2 alpha plus 4 alpha by 2 is 3 alpha e power t plus, sorry, plus uh, plus it's 2 alpha minus 4 alpha is minus 2 alpha. So minus 2 alpha by 2 is minus, sorry, it is minus alpha e power minus 2. And what is ut? 2 alpha and 4 alpha. 2 alpha plus 4 alpha is 3 alpha e power 2 plus alpha e power minus 2. And yt you got earlier, I got yt I got here e power t only. Yt is e power t. So what is the answer? What is the answer? Option A is the answer, right? 3 alpha. I got option A now.
Yes. Option. Yeah, yeah.
But this can be solved easily. Suppose this is dx dt is u now, and du dt is x, right? So I just what I did, I just differentiating again. I'm giving you a second method. I am just differentiating with respect to t both sides of this first equation. Understand?
Yes.
So equation becomes what? d2x dt2 equal to x. You know how to solve this equation. Develop.
Yeah. Auxiliary form and all that.
M square equal to 1, then I get A equal to plus minus 1. Then directly I can get C1 e
Okay.
power t plus t power minus 3. No need to this process, but I just solve in another process so that you can solve another problem in this process. No need of matrix, eigenvalue, eigenvector. Like this, that's Oikot told that time. Now, the derivative, using derivative, you can easily solve this. But I just solve in this way. Is it okay now? You can check,
Yes.
I'll give you a task that you solve this same problem using this double derivative that I give. Then you reach same answer. Okay, Biplab, just do it as whenever you get free time. Okay, hello,
Yes.
okay now, fine.
Yeah, yeah. It's fine. Actually, yeah. It is helpful for us because we learn new methods.
New method. Okay. So again, this problem can be solved by Lagrange multiplier and other things. But okay, it's already 7:30. So So, so with this, I'm stopping my lecture today. Is it okay? Any question from your side,
Uh,
brother?
so,
First of all,
so had
sorry, tell me.
yeah, sir, had a suggestion. Actually, I've taken other courses too, so the timings of the live session sometimes clash with that. So, can you please record the session from next
Yes,
time and upload it?
yes. Hello, hold on. Actually, these my all the lectures have been recorded. Okay, and it will share with you. The link will be shared with